Good morning, y'all. Sorry I am not there today. If you can please get out your notebooks, we are going to add page 16 into our notes. As a reminder, all homeworks are due. Make sure you turn them into my tray. We will trade and grade them tomorrow. So today we are going to be going over double angle identities. On page 16, please add double angle identities to page 16. All right. So your double angle identities, these are when you have two of the same angles. So let's start off with sine. We know that sine of a plus b, the sum, is sine a times cosine of b plus cosine a sine b. But what if I give you the same angle? Let's just say theta. So then I would get sine theta cosine theta plus cosine theta sine theta. Do y'all agree? And don't you agree that gives me two, you switch them around, cosine theta sine theta. This is our first double angle identity, because instead of writing theta plus theta, I can just write 2 theta. And that's the sine double angle identity. Now if we did the same thing for cosine, remember cos, sine, sine, cosine of the same angle, we would get cosine theta, opposite sign, minus sine theta, sine theta. And so that would give me the cosine of 2 thetas equals, what's cosine? Cosine squared theta minus sine squared theta. And this kind of looks like one of your Pythagorean identities, but why is it not your Pythagorean identity? Because it has that minus. Now, I could substitute in to my, let me get another color real quick. I could substitute in a Pythagorean identity. Like, let's say I don't have both sine and cosine. I could make this cosine, do y'all agree? Cosine squared theta is equivalent to 1 minus sine squared theta. Don't you agree that's equivalent? I just substituted in my Pythagorean identity for cosine squared theta. And this right here would give me (1 minus 2 sine squared theta). So this is also a cosine identity, double angle identity. You would use this one if you only had sine versus this one you have cosine and sine. And the same thing can be done over here for sine. So I could just leave it cosine squared theta. And instead, I can substitute for sine 1 minus, nope, that was wrong. 1 minus cosine squared theta. That gives me cosine squared theta, and distribute the negative, minus 1 plus cosine squared theta, which means that, which means that cosine of 2 theta also equals 2 cosine squared theta minus 1. So cosine, these all three are equivalent. You could memorize one of them and just know to substitute in. Like typically I use this one. The only reason these two come into play is if you only have sine or you only have cosine, then you don't have both, then you would use one of these. Okay, but all three of these are the same thing. Last but not least, we have the tangent double angle. So if you have tangent theta plus theta, remember that would give you tangent theta plus tangent theta over 1 minus tangent theta times tangent theta. That would become the tangent of 2 theta equals, what comes up top? Tangent theta plus tangent theta is 2 tangent theta over 1 minus tangent squared theta. Do you need to have these memorized? Yes and no. You need to know what they look like and which one belongs to which. But honestly, if you have the sum and difference one memorized, you can still use those. So like these will still not fail you. But I'll show you in a minute why you would need to know these offhand. Okay? If I went too fast, please pause this at any time, video at any time, so y'all can have time catching up writing. So let's do some examples. Example 1, find the exact value of 2 cosine of 105 times sine of 105. Which function is this? It's not tangent, so is this sine or cosine? It's sine. So we're going to do sine of 2 times, what's my theta? 2 times 105 degrees. So what is 2 times 105 degrees? The sine of 210 degrees. And again, we should be brain dumping our unit circle every day. What is the sine of 210 degrees? Third quadrant, so I know it's going to be negative 1/2. Bam. So these two are really good examples of, if you don't have the double angles memorized, you'll struggle a little bit just because you are have to be able to identify right off the bat what it is we're doing. All right, to find the exact answer, what function is this? The double angle tan. So 2 times what is my theta? 67.5 degrees. And what is 2 times 67.5 degrees? (135). And what is the tangent at 135 degrees? -1. Good job. All right, so that is working double angle backwards. We could also work double angle, forward. Let me look for my example. See if we're going to do that today, or if we're just going to go straight into XYR. Let's see. Yeah, let's go straight into XYR. I'm going to flip the page over. If you have room, you can do room. I'm going to flip the page over and show you what that looks like for XYR problems. So example 3, this will be the last example, but it's going to be a couple parts here. Given if my sine of theta is -4/5, where pi is less than theta is less than 3 pi over 2, can you find the sine of 2 theta the cosine of 2 theta and the tangent of 2 theta? So before we get any of these, what are we going to have to do up top? I gave you the sine. You're going to have to, off to the side, find the cosine and find the tangent, because you can't do any of these without that. So I'm going to give you all about 2 minutes. Find the cosine, find the tangent. Go. All right, I don't know if it was quite 2 minutes, but I'm going to go over it. I got sine is y over r. So if I know y is -4 and r is 5, what is x? But it's not just 3. It is in quadrant 3, so it's going to be negative 3. And so for my cosine, remember cosine is x over r, so negative 3 over 5. And my tangent is y over x, which is negative 4 over negative 3, which is positive 4 over 3. So now that I know these three things, I can fill in the rest of what I have. First thing we need to do, and I'm going to put lines over here because I want your final answer kind of right there. First thing we need to do is write our identity. So what is the sine of 2 theta equal? If you need to flip over to the front, the sine of 2 theta equals 2 sine of theta cosine theta. And so now we just plug in 2. What is our sine of theta? Negative 4/5. What is our cosine of theta? Negative 3/5. Now be careful right here. A lot of times this 2 out front kind of tricks you. If you need to, put it over 1. So you know multiply the numerators, multiply the denominators. I don't want you to multiply the denominators by 2 as well. The denominator there is a 1. So what is 2 times negative 4 times negative 3? Negative times a negative is a positive. 4 times 3 is 12 times 2 is 24. And what is 5 times 5 times 1? Bam. That is our answer. 24 over 25. And that's it. For the cosine of 2 theta, write the identity. And remember, 2 theta has 3 different identities you can choose from. I have this one memorized. So this is the one I'm going to do. You could choose one of the other ones. It's up to you. For instance, if you didn't find all this information and I just gave you sine, then you could do the one with just sine. But since we found the cosine, I like this one better. So my cosine of theta squared, my cosine of theta is negative 3/5. I'm going to square that. Minus the sine of theta was negative 4/5. I'm going to square that. Remember, when you square it, you are doing the top and the bottom. So negative 3 squared is 9. 5 squared is 25. Minus negative 4 squared is positive 16. And 5 squared is 25. What is 9 minus 16? That's it. Negative 7 over 25. All right, last but not least, we have the tangent of 2 theta. So for my tangent of 2 theta, the identity was 2 tangent of theta over 1 minus tangent squared of theta. And I'm going to plug in. My tangent of theta up top was 4/3. And remember that 2 is like 2 over 1. So that's going to be 8/3. So it's not going to be 8/6. It's going to be 8/3 because it's like 2 over 1. Over 1 minus 16 over 9. You can do this a couple different ways. The first way I'm going to suggest you do this is just to multiply everything by 9. When you do that, we get 8 times 3 is 24 over 9 minus 16, which is 24 over negative 7. I'm going to put the negative out front. It doesn't matter where the negative goes. Oops, sorry. If you wanted to instead right here, you could have, so this is or, you could keep change flip by finding a common denominator here. 9 over 9. That's going to give me 8 over 3 divided by negative 7 over 9. If I keep change flip, this is going to give me and then I get 72 over negative 21. And I can divide them both by 3, which gives me negative 24 over 7. You could also reduce that right there and got 3 and got the same thing. Okay, that is it for my lesson today. For the rest of the class period, you are going to be working on your homework. If you look at your calendar, and again, you can choose one of these ways. You don't have to do both. If you look at your calendar, we're right here on the 20th. On Wednesday, you have due this double angle identities worksheet. The sub's going to pass that out right now. All of it is due. It doesn't just say evens. So all 7 problems are due. As well as you have these 1, 2, 3, 4, 5 problems on page 250 or 352. We should have some time in class tomorrow to do the book work. So right now what I would like you to do is the sub is going to pass out this worksheet. Just write due Wednesday 10/22, and all of it is due Wednesday. So you could probably finish this by the end of class, maybe not. But get started on that, and that is it. Thank y'all so much. I hope y'all have a happy Monday, and I will see you tomorrow.